You can start.
Okay. We may not. Anybody coming now? All right. So, so today my voice is a little bad. So please bear with me. Today we'll be doing statics and mechanics of material. If you look from our CBT specifications, we have about, on average, like 8 to 9 problems coming from statics, and about the same from mechanics of material. Mechanics of material range 7 to 11. So roughly last week what we covered, it's about, I would say, between 17 to 20 problems what we did last week, mathematics, probability, and computational tools, and little bit more today. It's about 50, again about 20 problems, 18 to 20 problems. So if you add them together, we have covered about 40 problems. And remember, your goal is to pass the exam. You need about 60 correct, okay, 60 to 65 problems correct. Now, statics and mechanics of material, these are again fundamental basics. These things you can definitely get it right because they're at very basic level. Problems are relatively easy, simple, and obviously if you are a civil engineer, you have taken many more courses where you applied this basic knowledge, such as structural design. But you will see from your exam specification, the structural design, which is obviously based upon these principles, has very small component, just 6 to 9. Concrete, steel, timber, anything that you have learned, it's only about 6 to 9 problem, very small component. So now let's start with manual, reference manual. So reference manual, obviously we have a static section. Static section is again a common section between many engineering fields, and oftentimes including mechanical for sure. Now oftentimes when that is the case, you have to be a little careful because it's a general topic now. You don't have to cover everything. So for civil engineering, what we have to cover is basically, now we have to really carefully look what we want. From civil engineering perspective, we need resultant of force system, equivalent force system, finding out the resultant, equilibrium of the rigid body, frames and trusses, centroid, moment of inertia, static friction. That's about it, nothing beyond. So but your again, this is obviously a complaint that you will see everywhere. This manual is too broad. Sometimes even the review manual that you have, not all topics are going to be part of your exam. So what it means is basically sometimes you are over prepared for the exam. So do not try to master everything that you have in the manual. Always keep in mind what you need to learn, and maybe that will save you some time. So it starts with the definition of force, and it's all pretty straightforward. How to get the resultant of a force, how to get the component of the force, and again, as I said last time, the notations are slightly different. Make sure you read it so that you understand what these things are. And also it's a good way to look at these concepts after you have taken this course maybe few years back, right? Most of you have taken statics a while ago. So it's good time for you to review everything. So everybody is clear with the component, how to get the component resolution of a force, X component, Y component, normally we call, or it could be anything. In the real world, there is no X and Y. X and Y is our choice. So taking component. And the way I always recommend my students to remember is, if you're taking a component of a force along any axis, it could be X, Y, Z, or whatever axis it is, all you need is the near angle, right? So near component is going to be cosine theta. So farther component, meaning this component, is going to be sine theta. Cosine is the near, sine is the far. Meaning you can put this wherever you want. As soon as you have one angle, you can take the component along that will be cosine, and the perpendicular is going to be the sine. And this can be extended to 3D and so forth. And also this gives you another important definition, which briefly we used in our vector portion of the math section last week. That is, you can take this information and generalize it to 3D. So we can define a force by its magnitude and the direction. And direction we can define how much angle it makes from the x-axis, how much angle it makes from the y-axis, how much angle it makes from the z-axis. Those angles are called as the direction cosines. Y direction because they're giving you the direction, cosines because we can find them using cosine. So we can take the x component, divide with the magnitude. That's what these relations are trying to tell you. The cos theta x, theta y, these are the angle from the positive x, y and z axis. Positive being really important. It's not from the negative. If you do negative, it's 180 minus theta. So these angles that we have, they are from the positive x, y and z axes. Using that, we can find out those direction cosines if you have to. Then we have a definition of the moments. Couple, sometimes we call them couple if they are equal and opposite. Forces are equal and opposite. And for moments, mathematical definition is R cross F, meaning Again, remember, you cannot switch the order. You cannot do F cross R. It has to be R cross F. If you do F cross R, you have to change the sign. R cross F. R is the location, F is the force. So two vectors that we have, the location vector and the force vector, if you take a cross product, you get the moment. And this is how, this is another way of writing how to open that determinant, right? You will